Same direction or opposites?
Opposite.
Opposites. In class we did opposites. When did we do the same?
Then it'll still be opposite.
All right. What are our steps here? One thing I did in period 2 that I didn't do in period 1. Let's break it into 2 problems. We'll find out what one wire is doing to the other wire, and then we'll find out what the other wire is doing to the one wire. Okay? That'll help keep them separate. Does that make sense? Okay. What is the direction of the magnetic field around wire 1? Out on top, in on the bottom. So it's out on top, in on the bottom. And that's true for both, right? Is that clear? Out on the top, in on the bottom. Yeah? And B2 is the same, isn't it? It's the same directions to the magnetic field. Something like that, okay? So far, so good?
Yes. So everything on, so when you're splitting them up like this, that was in your first period class, so we're doing 1 on 2, so everything below the bottom will be the same as like just going to the page, right?
Everything over here will be below the page,
Yeah.
into the page, yeah. Okay. So, what's next? Can we say what the direction of the force is F1 on 2?
What is the current?
The force due to B1 interacting with wire 2.
The force is into it. Wait.
Into the page?
Yeah. Or no. Into the, like, towards the, into the middle.
Okay, looks like most of you got it. My magnetic field's in, my velocity's over that way, so my force is up.
Here, check.
Does that make sense? Field's in, velocity's down and to the right. This might be better. So my force is up. There you go.
Okay, yeah.
Is that better? What is the size of the magnetic field, B1?
We don't have any current.
We don't have anything, but we could write B1 equals mu 0 I, which I?
I2. No.
I1.
1.
I1. This current creates this magnetic field, so it's better be I1 in there that creates B1.
We don't have
I haven't given you an R, but R is going to be the same. Then what is the force that's created?
I2 LV centimeter.
First of all, it's B1 because it's this field due to wire 1 acting on wire 2. And which current? 2. It's this field acting on this current, which produces that force. Does that make sense?
Yeah.
All right, so what's the direction of F2 on 1?
Attracted to southwest.
Field's out, velocity's down and to the right, left, so the force is like that. Okay, so it's like that. Okay. Field's out, velocity's down and to the left, force is perpendicular to that. Okay? And we would use the same formula. B2 equals mu 0 by 2 pi r, and F2 on 1 equals I1 L B2 sine theta. What's sine theta in these situations? It's 1. So what is theta in these situations? 90 degrees.